Okay, we're going to start our periodic table notes with a quick review of our elements on the periodic table and what uh, each element square stands for. So remember, in your foldable that you put together, okay, this number right here is our atomic number. Okay, and it tells us the number of protons and electrons in a neutral atom only. Neutral atom only. Okay, it will always tell us protons, but it only tells us protons and electrons in a neutral atom. Okay, here's our element symbol. Okay, here's our atomic mass, which is our protons plus our neutrons. Okay, and then this is our element name. And remember, this square with this information, well, some of this information is always on every periodic table. There's always an example. So now let's look at our little foldable of our periodic table. We're going to be writing down a lot of information. You've already been using the periodic table to calculate atoms and draw your Bohr diagrams. So now we're going to use it. We're going to learn how to read it a little bit better. Okay, it's a little bit blurry, trying to make it better for you. Okay, so let's start with our 1 and our 2 on here that it's asking about. We're going to fold this back up. And the first thing is it says, what is represented by number 1? Okay, what it means is what's going on here with our number 1. Okay. and number 1 is going to be our groups or our families. Okay, we call them groups or families because everyone in the same group has similar properties to each other. So everyone in group 16 or 15, excuse me, is very similar to each other when it comes to how they react. Okay, and we'll talk about why in just a second. Okay, how many groups or families are on the periodic table? If you can see, we have to start here with 1. I'm going to go all the way to 18. Okay, the next thing it asks, what are some similarities amongst elements within a group? Okay, now here is where the reason why everybody in the same group has similar properties is because they have the same number of valence electrons. Okay, so let's write that down. They have similar properties. Okay, which groups are the most reactive? Okay, let's back up just a little bit before we answer that and go back to the valence electrons. Okay, our group number is also going to tell us, for some of these elements, it's going to tell us our number of valence electrons. So group 1, because it is in group 1, everybody in group 1 has 1 valence electron. Okay. Okay, so everybody in group 2 would have 2 valence electrons on their outermost energy level. Now, 3 through 12, we don't really talk about in the 8th grade, and they don't really follow this rule that I'm about to teach you. Everybody in groups 3 through 12 have 1 or 2 valence electrons. Okay, it just depends on who they are. Okay, so let's start back up here with our rule. Group 1 has 1 valence electron. Group 2 has 2. We're going to skip here. When we get through 3 through 18, what we're going to do is drop the 1, and that means group 3 has 3 valence electrons. Group 13 has 3 valence electrons. Group 14 has 4. Group 15 has 5. Group 16 has 6. Group 17 has 7. And group 18 has 8. Okay? So that's a great rule that you need to memorize that will help you remember the number of valence electrons. Okay, and again, because everyone in group 1 has 1 valence electron, they're all going to react in similar ways. They have similar properties to each other. Okay, so let's talk about reactivity. Well, remember when we're talking about drawing Bohr atoms that our electron shells are full at either 2, 8, or 18. Well, here we only have 1 valence electron on their outermost shell, which means if they had 2 energy levels, they have 7 more electrons to fill, which means they're highly reactive. Okay, so group 1 is our most reactive. Our next group is group 17, and we'll talk about why. So, group 1 and 17, okay, again, because, like I just said, group 1 wants to give, they have an opening for 7, or they can give their 1 up to another bond. In group 17, they have an opening for 1. So in group 1 or group 17, they're either giving up or receiving 1 electron, which makes them highly reactive. Okay, that makes them highly reactive. So what we need to know here, okay, is as we go from, let me write in a different color, okay, we go from most reactive, okay, our reactivity starts to decrease until we get to group 17 that is most highly reactive as well. I'll put highly. Okay, until we get to 17. And then group 18 is non-reactive at all. And the reason group 18 is non-reactive is because all of their electron orbitals, or their shells, are full. They don't have any room to take on electrons, and they don't have any room to give up electrons. So they're full, they're stable, so they don't react at all. Okay? Our special name for group 18 are our noble gases. And they're called noble gases for that reason, because they do not react with anybody else on the periodic table. Okay? Group 17 that we're talking about, that's also highly reactive, those are our halogens. Okay. All right. Now let's go look at our number 2. So our groups, we just learned all the information that we need to know about our groups. Okay, so let's look at our 2s. So now we see that we're moving along the periodic table horizontally instead of vertically. Okay, so when we move this way, those are called our periods. Okay. Okay, how many periods are on the periodic table? If you look, we have 1, 2, 4, 5, 6, 7. Okay, and what do we know about everybody in the same period? Okay, everybody in the same period, so going this way, everybody in the same period has the same number of electron orbitals, or electron energy levels. So, everybody in period 1, okay, which is only 2 people, they only have 1 energy level. So if you were to draw it, it would only have 1 ring. Everybody in period 2 has 2 energy levels. Everybody in period 3 is 3, all the way down to period 7. Everybody in period 7 has 7 electron orbitals. Okay, a good way to remember how periods and groups run. Okay, groups. If we do groups, we make a long G. Okay, so we can remember groups run up and down. And for periods, we can make a long, okay, periods run side to side. Okay, it's a great way to remember the difference between groups and periods. Okay, now let's talk a little bit more about where everything is on the periodic table. In the 6th grade, you learned about metals, nonmetals, and metalloids. So let's go over that. Okay, right here, it's hard to see, so I'm going to outline it again with my marker. We have a stair step. Okay, everything to the left of that stair step are our metals. Okay, everything, so we have our most reactive metals right here. Okay, then we go to our next reactive metals all the way till we get to the stair step. Everything on this side of the right side of the stair step are going to be our nonmetals. Now, nonmetals does not mean just gases. Okay, some of these things over here are gases, but some of them are not. Okay, so just because it says nonmetal does not mean it's a gas. And then everything that lives on the stair step are called our metalloids. Okay, and they have properties of both metals and nonmetals. Okay, we will talk more about, I don't know if you were able to see the reactivity part. Okay, there's the reactivity part for, okay, remember group 1 is our most reactive, and then our reactivity decreases across the periodic table until you get to group 17. And group 17 is highly reactive as well, remember, because it has that 1 electron to gain or lose. Okay, and then group 18, the very end of our periodic table, is non-reactive because its energy levels are full. Okay, if you weren't able to see that earlier. Okay, we will have a lesson over metals, nonmetals, and metalloids so you can remember the properties of all of those things. Those are things you learned in the 6th grade that we're going to go back over.